Hey, folks. Good morning, good afternoon, wherever you may be tuning in from. Good evening. Welcome back to a special session. We're going to be doing a more developer-oriented stream here today, featuring Thomas Honeyman. So this is really exciting to have Thomas back on the stream. Hello, Thomas. How are you?
Hey, it's great to see you again. Good to be back.
Great to see you. So for folks that weren't here for the last video, Thomas is a senior engineer at Awake Security. He's an awesome technical writer, programmer, functional programmer. He's been heavily involved in the PureScript communities. He's done a lot of work in terms of security and had some exposure to formal verification and has just an amazing background, great technical writer. And he has been working with Kadena and Kadena Eco in terms of writing some projects in material that can help introduce people to concepts involved with Pact, as well as writing example code in projects and sort of tutorials that can help people go from zero to hero, if you will. And so really stoked to discuss the latest development, which is Charka, and learn from him more. I'll just sort of add one preface at the beginning here that any code that we walk through and discuss today is sort of development grade code. It's not meant for production.
That's right.
So it's not meant for it to be a operating crypto project tomorrow or today. However, if someone wanted to use that as inspiration to learn a whole lot and then write some stuff for production, that would be awesome. So just wanted to add that quick caveat. But yeah, Thomas, would love to hear also your kind of informal intro for what you've been working on the past few months in terms of the tutorial series and projects and now Charka.
Yeah, I'd love to. So yeah, this Charka is the final project for now. There may actually be more in the future projects, but it's the final project for now in what's called Real World Pact. And it's a collection from beginner to advanced of real world contracts that you might write in Pact and have in a fully functioning ecosystem. Charka is specifically a lending platform. It's essentially a clone of Compound Finance, which was one of the early and most successful of the lending protocols on Ethereum. It works in a similar way where it is a collection of money markets where you're able to buy short-term debt, or not buy, but you can take on short-term debt in cryptocurrencies for the sake of either meeting like a short-term obligation, or you want to trade in an asset, but you don't want to actually liquidate some other asset you have. For example, let's say I have Kadena, I'm expecting it to appreciate, but I want to do something with some Ethereum for a moment. I can do it without selling my Kadena by pledging it as collateral and then borrowing Ethereum. Also can help you avoid things like capital gains exercise which can happen when you sell an asset and then swap it into a different asset. So there's all sorts of reasons why you might use a lending protocol, and they're definitely part of the backbone of a thriving DeFi ecosystem. So Charka is a fully functioning one of these, but as Tyler said, while it does work, it's more intended as a reference for other people who have their own ideas about the financial side of things, but maybe don't know how to translate their financial model into a collection of Pact contracts, because it's not all. It sometimes can be non-trivial doing blockchain development. So that's the point of it. And as we get into the demo a little bit, I can showcase some pieces of it, which include a white paper, so kind of very common for crypto projects, into a development guide that translates the white paper into Pact code, and then the fully functioning, all of the contracts. There's a front end for it, so we can play with the front end a little bit. That looks a little bit like Compound Finance. So it's the whole thing, and it's all pretty fully commented. It's a great way to learn a more advanced project in Pact.
Awesome. And so for those that are just joining us, the Real World Pact project has a GitHub repo where most of this lives, and there's also some accompanying Medium articles. We have the lending protocol one down below, but there's a full series of introductions that go through, first of all, some core concepts, then a faucet contract for how to build a wallet, which is kind of like a hello world, if you will, of blockchain and crypto, followed by a Goliath wallet project, which is starting to get a bit more sophisticated, a fully functional wallet with multi-chain introduction on Cadena, and now the Charkha Lending Protocol. And so through this series of writing, these sort of tutorials, as well as these example projects and code, if you check out Real World Pact, you can literally go from having never written a line of Pact before to having the capability of understanding and writing a functional lending platform. And I think that's a pretty freaking awesome curriculum. And so just hats off to Thomas for making this happen. And I hope that some people on the stream here today might be inspired by looking at some of these resources to then say, hey, you know what? I got some time this afternoon or this weekend or whenever it may be, or after this live stream, and to say, hey, maybe let me dive into this and read this and see how well I can understand it and play around with it. And you might be surprised to find out that a lot of these concepts aren't very complicated. They may be new and you may be exposed to new ideas, but the actual process of walking through it and writing it and integrating, so much of it is just about knowing what the tools are and seeing some examples and understanding just how the foundations work. And then once you get that, it becomes a lot easier to actually translate that into real new ideas. So without further ado, we can jump in. But yeah, I'm just super stoked that we've made it here to part 3 with Charka.
Yeah, me as well. Actually, I'd love to share my screen
please
for a moment, and I can show some pieces of this. Let's see if this will let me. Okay. That come through okay?
Not as of yet. As always with, oh, there we go. I see it.
Oh, okay. Yeah, I was about to give you the infinite screen. Oh, okay, so if you can see the GitHub repo, then we're good to go.
I can.
Okay, perfect. Yeah. So, and also, by the way, if there are audience questions at any time, feel free to interrupt me and I can answer those. Things in particular that I'd be good at answering relate to especially translating maybe some ideas that you have for a protocol or product that you'd like to exist in Chain Web, but you've maybe struggled with some ways of translating it into Pact. At this point, this is a fairly advanced and serious Pact project. So definitely happy to answer some more technical questions on that side. I have some financial understanding as well, but I'm probably not the right person for too many finance-oriented questions. But yeah, without further ado, the first thing that I wanted to show was just the core concepts guide here in Real World Pact. The reason I want to show this first is just if you aren't familiar with the language, there's this article, Learn Pact in 20 minutes. And it literally starts with you don't know anything and builds up your fundamental of understanding Pact in about a 20-minute long article. So if you are seeing this stuff and you're feeling inspired, but you don't know how to write Pact at all, fantastic place to start. And then from there, you can jump straight into the other projects. So Real World Pact is pretty self-contained in that respect.
Right on. So there you go. That's the place to start. Learn Pact in 20 minutes. Great way to kick off.
Just 20 minutes. It's all you need. Understanding Pacts truly will take you a little longer, but it's a good start. So this is the repository. It's got all the information on everything in here, some little helper projects and utilities for you to use. But the one we're going to look at today is Charka, which is named after a silk spinning wheel, kind of traditional spinning wheel. And this is, like I said, a clone of compound finance. In particular, the things to look for here, the first thing is the white paper. So this is a full-on white paper that explains what the lending protocol, like what's the point of having one of these things? What is a money market? What are some of the fundamental blockchain concepts involved in making one of these? So for example, well, actually, a good place to show some of the components here is actually a separate section called the development guide. And this development guide takes the white paper that I just showed you. That's all very like high level. It's like the financial formulas, it's understanding how these markets are formed. And the development guide, in contrast, takes those ideas and says, okay, now we're actually going to put that on the blockchain. How do we translate those concepts into like actual contracts that need to exist? And being a lending protocol, there's all kinds of things that you need to exist as part of the protocol and also on chain, separate from it. So one of the first things you can see in here, for example, are price oracles. In this project, we implement our own centralized oracle based on CoinMarketCap, their price feed. It's not usable as like a general purpose oracle, but it's suitable for the purposes of having live prices in the app. But there's other things like we implement our own token called Charka. It's a governance token that can be used to vote on changes to the protocol, like adding new markets, like changing the interest rates that are applied to different assets. So this lending protocol it's got it all. It's got the fundamental behavior of lending, but then also other stuff that you expect to be in a crypto project, from white paper to an actual governance mechanism for changing the protocol over time. Everything's transparent, everything's on chain, every transaction can be seen. You can see the interest rates that have accrued, all that stuff. So at any point we can dive into these, but
Awesome.
the fun stuff is definitely Charka itself. So I can show that in a moment.
Right on. So I'll take a look at two questions here from the chat. First, from Canadian ecosystem. Perked my interest when I heard Goliath Wallet. Can't wait to hear more about what that is all about. Well, good news for you. We actually have a stream we did a few weeks ago on Goliath Wallet, and maybe we can get a link posted to that here in a moment. But we have a full walkthrough video of Goliath Wallet, and you can check that out. And once again, it's a wallet that is really intended for developers to learn how to build Pact applications and wallets.
Yeah, and just to clarify a little bit on the wallet, it's not really a fully functioning wallet, like implementing Wallet Connect and that kind of thing. It's really more of a wallet user interface. The main point of that is to demonstrate building a front end and connecting to an existing set of contracts on chain. So in project one, you'll write a faucet, and then in project two, you're implementing a UI, and it's a wallet, and it's showing like, oh, I want to reward new wallet users by sending them some funds, and that's done via the faucet. But to be clear, you're not really learning like to implement a full like smart wallet like Koala is or something like that. Those can be pretty technically complex. I'd be interested in building one of those as a full example, but that project is more about connecting a front end and implementing like a TypeScript front end with the Pact API.
And then thanks, Canadian Ecosystem, for this good suggestion and thought. Hope some of these articles you include in the docs page, linked on the main website instead of in GitHub repos. Yeah, I think as a software developer, GitHub repos are awesome in that I can just git clone Thomas Honeyman / real world Pact, and then I have everything on my computer locally. I can bounce between looking at the code and looking at a tutorial or opening a PDF. But you're exactly right. For discoverability, finding ways to get this in front of more people is definitely great. And we'll take that feedback and bring it up to some of the team, especially with the website redesign happening as well. So yeah, thank you for that idea. And welcome to more folks joining the stream here. Always great to see the discussion and the chat. So please keep it up. And if you have any questions at all, feel free to ask. And if you are confused about something or don't understand something, I can promise you that there's someone else on the stream that's probably confused about the exact same thing. And so please feel free to ask any questions. No authentically asked question is a bad question. And we're happy to help accelerate folks' learning as much as possible.
Yeah, fantastic. Interrupt me if any other questions come up in the meantime. But what we're looking at here is, I just wanted to show you the actual running app. There's a backend, there's like a chain web test network that you can run locally called DevNet. So right here, you're seeing me start that up in real world Pact on my machine.
Awesome.
And
so just to
then,
contextualize for some folks, we're now in VS Code, which is a very popular sort of IDE or text editor for writing software. And Thomas has opened up the real world Pact repo, and now he's at the command line at the bottom. And if you haven't seen this before, you might want to go back to the 2 previous videos we did with Thomas that will provide some additional context and a slower ramp. And as now we're about to get pretty advanced, if you will.
well, the big point is to get us here. So this is the actual UI. It's pretty bare bones, but this is the UI of Charka. We can see in here, these are live prices that have been fetched, and for Kadena, for Keth, which is Kadena wrapped Ether. So kind of an example of wrapping of bringing liquidity from one and bringing assets from one ecosystem to another. This would require a bridge. So we've got a faked bridge built as part of this. It's not usable in actuality, but it's suitable for test purposes. And so as part of the project, you do learn how to implement your own wrapping token like this that has special behavior around minting and burning, since it's not like something that you mine or something like that. It's something that's being brought from another ecosystem. And then Charka, the governance token itself, which interestingly enough is not just used for governance and for rewards, but it is a money market of its own with its own interest rate and everything. So what we're looking at right here are different markets supported by the protocol. Each one of these has a supply of how much people have lent at any given moment and how much people are borrowing at any moment. And the amount of borrowing over the supply is what's called the utilization rate. And this is used by Compound, many protocols, as a way of gauging what is the supply and demand on an asset right now. And when there's a high utilization, it means that there's a lot of pressure that we might be actually getting to a point where we run out of this asset. Like people want to borrow and they can't. And so the function of a money market is to set a price on money, on taking out these loans. And as a supplier, it's like a savings account for you. You are looking to earn an interest rate. And so the interest rate that you're earning is being paid for by the borrowers. And so the interest rate serves as the price of the money. And we can see here what those interest rates are. So right now, if I supply Kadena, then I'm going to get roughly an 8% interest rate on it. And if I borrow it, I'm going to be paying around a 14% interest rate. And the reason that those are different is that some of the interest paid is reserved by the protocol for situations where maybe there's like a lot of market volatility and we need to dip into platform reserves and put a little bit more Kadena to be available. There is small but some risk of bad debts arising in a lending protocol, and so it's used to cover that kind of thing as well. Yeah, so that's kind of the basic function of one of these markets. And what we've done right now, our account, we've gone ahead and we've lent 10,000 Kadena. So we're actually earning a bit of interest. And with the amount of interest that we're earning, we are also earning the governance token, Charka. So the last time we claimed a while ago, we had just a little bit of Charka. We can try claiming it again. Again, this all stuff is fully functioning. It is just a recently updated demo, so something in here might break. I can't promise it'll be perfect. But everything in here, you can run this yourself locally. You can tweak it. You can change the code and adapt it into your own ideas. But it is all fully functioning here.
Right. So trivially, someone could say, hey, I want to change that reserve ratio, or the rather, I shouldn't say the reverse rate, the platform portion of the interest rate. You could make that, a different number, or you could change some of the incentives. But I think if you look at sort of the raw structure here, the core concepts are to understand how, hey, look, these are money markets. There's this interest rate mechanism to sort of price the different borrowing and lending. And then there's these two roles of users, either people that are supplying a particular asset or people that are borrowing a particular asset.
Right. And importantly, yeah, so in the governance here, just really quickly, this is kind of like one of the last pieces of this. You have supplying and borrowing, and those are the main functions of of a lending protocol is kind of the whole point. But two other pretty important functions. One of them is governance. It's saying, hey, you know, we at first thought that like the interest rate base rate should be this, but now we're noticing that like it's not really allowing the market to function the way we wanted. So we'd like to change what that rate is. And you know, that's something that's really good for a community to be able to manage instead of being like a fixed thing forever in the protocol that can't be changed, or something that can be just changed like at a whim by the protocol developers. And that's what's really interesting about like Charka is that there is no like admin key set that can touch any of this stuff. It is a protocol account that nobody controls. It's like purely mechanical. And so if you want to change this, I, as a developer of the protocol, I can't just come in with an admin key set and just change the interest rate of something. It has to go through this voting process. So that's what we're seeing here is a new proposal that I'd made. So you can like make these proposals, submit them, and do some voting. I'll show that in a moment.
Super cool.
But the last thing that's in here, and it's not actually in the user interface here, but it is in the tests. There's one other really important factor in a lending protocol. It's the last one. It's called liquidation. And liquidation is for when somebody has taken out a loan and they put up some collateral. Everything has to be over collateralized. You have to, you know, if I want to borrow Cadena, I have to have lent a different asset that serves as my collateral. And the reason that's necessary is that if I don't repay my Cadena ever, and let's say that the value of Cadena spikes, and so my collateral is worth not enough to cover my loan, what happens if everybody starts withdrawing from the protocol, but I never paid back my debts and my collateral is not worth anything anymore? Well, now the platform has incurred a bad debt. And since there's nobody managing this, we can't like go to the government and say, give me a loan, bail me out. The platform needs to be self-balancing in a way that prevents these bad debts from arising, or if they do start to happen, catches them early. And one way that's done is with liquidators. And what they do is they are allowed to watch for accounts whose collateral is no longer sufficient to cover their debts, and they can liquidate that collateral, or they can liquidate the loan. And so they get part of the assets that person had held. So if I borrowed Cadena, then a liquidator can pay back my Cadena debt, but in exchange, they get my collateral, maybe my Keth or whatever. They get my collateral, plus they get a liquidation fee on top of that. So I pay a penalty for having been liquidated, but my debt gets paid off by somebody else. And that keeps the platform in balance and prevents bad debts from arising. So that's another function in here as well. Cool. Yeah, so a little bit of a whirlwind. So these platforms can be pretty complicated. The white paper is only like 5 pages, but there's a lot of formulas. It's really interesting to go through and see how this plays out in practice.
So yeah, I definitely want to make sure we have a little bit of time to jump into some code and discussion there. But just to recap some of the core concepts and pieces you brought up here. So some of the functionality is you as a user could come on here to lend an asset like Cadena.
Yeah, right here, we're going to try and lend a little bit of Charka. I'm going to check what our borrowing. So this is our borrowing capacity. When I was saying that you put up collateral and then you can borrow assets, these platforms are generally over collateralized, which means that you have to borrow $1,000 worth of Cadena, you must have put up, you know, maybe to borrow like $1,000, you have to put up like $1,100 in a different asset. And that way, if those values slip, I can get liquidated and my collateral is still enough to cover. So here I can see what my borrowing capacity is normalized to US dollars. I've lent 10,000 Cadena. It's got a collateral ratio that says, you know, I can borrow up to 70% of what I've put in. So I can borrow about $4,300 worth, but I'm actually gonna supply a little bit more. So this time I'm gonna be the first lender in the Charka market. And since there are no borrowers, I won't earn interest, but I'll become a supplier. But this is basically like as simple as it is. Like in order for me to become a lender and start earning interest, I don't have to prove who I am. I don't have to like fill out any paperwork. There are no terms. There's nobody like an intermediary in the middle telling me what I can and cannot do. I can withdraw at any time. It's fully just an automated system, which is pretty phenomenal that these are able to work in these blockchain environments.
All right,
so yeah, there we go.
See the balance.
I'm supplying it. I'm supplying some Cadena. Let's see, what else might I want to do? I could do some borrowing. So I could borrow one Keth. And after this, I'm going to redeem my 10,000 Cadena. And you can see that I've actually lent 10,000, but I've earned a little bit of interest just in the few minutes that we've been running this. Let's see, I'll redeem. I don't have that. What do I have? Oh, this is a bit of an odd error message, actually. Well, right now this protocol is closed to Cadena redemptions, I guess, and I'll have to look at why.
Well, good segue to jump into looking at some of the code. I think we can.
It is
maybe
actually I just realized why this is. This is a bad name for this. So what happens in one of these protocols is that when you lend Cadena, I put my Cadena into one of these pools of assets. So I put in 10,000 Cadena. Somebody else puts in 20,000 Cadena. They all get mixed together into what's called a pool. And so when somebody else comes in and they borrow Cadena, it comes out of that pool. They might be getting some of my Cadena, some of somebody else's. It's all mixed together. And what happens though is when I put my Cadena into the protocol, I literally send my Cadena from my account to the protocol. And what I get in exchange is what's called Charka Cadena, CKDA. And it's about a 50-to-1 exchange rate. So if I put in, 5,000, I'll get like 100 CKDA. And what happens is when I earn interest over time, what's actually happening is my exchange rate is changing over time. And it's getting better and better and better. So when I finally go back and redeem my 100 CKDA, instead of getting 5,000 Cadena back, the exchange rate has grown over time. And now I'll get 5,100 Cadena back. And the reason that this is done instead of just constantly accruing to my account is because you don't want to pay gas constantly. Like every block that I earn some interest. I don't want to actually send that to you, because if I actually send that to you, I'm going to pay a gas fee on every single one of those transfers. So to prevent an exorbitant amount of gas fees, instead you get these 50-to-1 tokens, and that exchange rate changes over time. And so what I'm actually redeeming is not Cadena. I'm redeeming my CKDA. And so, yeah, I don't have 5,000 of it. It's 50 times less.
Got it.
So anyways, I'll let that redeem in the background, but we've basically seen the platform features in general.
Yeah,
you can see my lending, my borrowing, and the markets.
So basically what we just saw there was a small, a small bug where basically the amount of KDA you want to receive is actually in sort of a different unit of number. So if you type in 50, that actually means 2,500, that kind of thing.
Yeah. And then here is because sometimes in Pact upgrades, the gas limit on things will change, or the gas costs of different operations will change. So obviously I did not set a high enough limit, so I'll have to fix that. Live demos.
As always with live demos, it's a great opportunity and an excuse to dive into some code and learn a little bit more about what's happening under the hood.
Yeah. Before we do, were there any questions to answer in the meantime, or should I just get right to it?
I think we can jump right to it.
Okay, cool. Let's see. I don't have the time, but let me know if I'm.
But we got solid. I think we can maybe walk through the code in 10-15 minutes, and then we'll have another couple minutes for questions.
Okay. Yeah. Awesome. So here's the lending project. So it's the third project. White paper in here, the guide that we already saw. The two main pieces in here. I'm not really going to go through the front end, but we do have a full front end that interacts with the different contracts and all that stuff. I'd recommend you, if you're interested in how some of the more front end stuff works, the prior call that we did talks about that more. But what we're going to look at is the code for this protocol. So the way that it's broken down is...
Actually, let me address one question. So Tier, why are you doing a development tutorial when the product is not released, audited, or tested? So this is not a product, very explicitly, not a product.
Not a product.
This is not going to be a project that will be, live on Cadena, anytime soon, and nor is there an intention for it to be live ever. However, it's meant as a as an example project of something that's a lot more complicated. So this is a fairly advanced project, and it's incredibly well commented code. So the intention here is for someone to come in and learn how to build something that contains a simple price oracle, that contains a simple, bridge token, and a governance and rewards token, and a market token, and governance contract, and controlling contract, and learning how to write all those pieces and put them all together. This code is not going to be audited. But if someone were to use this as a basis for a lending platform, they absolutely need to test it, audit it, harden it. I would not suggest that someone tomorrow just clone this code and start their own lending protocol. If they clone their code, played around with it for a couple of weeks, went through some serious audit process, hardened it, then maybe in a couple months they could have something that was more viable. So just wanted to address that. Thanks for bringing it to my attention that I missed your question.
Yeah, and there's not on this page, but there are some disclaimers kind of in here. The point of this is to be a reference. It's to see, how do I take my idea for a product and translate it into some fairly advanced Pact code. There's not really anything like this in the Kadena ecosystem so far, where you can look at public code that's explained like this. So that's the motivation here. It's not to release a product, although this isn't, it's intended to work quite well, but it has not been audited. So don't just fork it or anything like that. So as you can see, this white paper, this protocol, it's all broken down into a collection of contracts that starts at the very low level with the oracle and the Keth token. So these are implementations of like KIP5, implementing different tokens. And then on top of that, we start building markets. And then on top of that, we build this like overall, bring it together, top level contract. That's the main thing that everybody interacts with. Before I look at any of those, I also want to show that we have a pretty thorough test file in here. So if you are not used to seeing what like REPL files look like, I definitely recommend in the core concept guides, there's one that's all about testing formal verification in the REPL. But in this, we have full unit tests for all sorts of protocol operations. Everything's commented out, explaining like how the protocol should work and why each test is happening. So it's too long to go through here, but it does explain how everything is meant to work, and then shows you how you would call it in your own contracts. There is also a fairly short verification test here, which runs the formal verification, which is just basically calling verify. So it's in 10 to 15 minutes, it's kind of tough to go through the code at anything more than very, very surface level. But just some high level stuff here. One, the oracle is probably the easiest little one to look through. This is just taking some real world information from an API, and then an admin key set being able to just write to a database in here. So this is a very, very simple little contract to read through. Again, pretty thoroughly commented. But the ones that are more interesting.
So yeah, I'll also just add a brief plug that, as you can see, all these sort of gray text, these are comments that are all human readable with additional links and resources to help explain concepts. And so even if you aren't a developer, I've actually shown some of Thomas's code to some people that never looked at crypto or blockchain before, and they've been able to look at it and read it and sort of understand at a high level what's going on. And so if you want to just sharpen your technical understanding of Web3 and crypto, I would really encourage you, even if you aren't a software developer, to take a stab at looking at some of this code and reading through the comments. And I think you'll be pleasantly surprised that you're able to understand decently well everything. You might not understand, why is there 3 arguments or 3 different, symbolic strings in between these parentheses, right? You might need to go back and look up, okay, what does enforce mean and what's going on there? But you will probably be able to understand at a high level, like, oh, wow, it's enforcing that a price is above 0. And so connecting the syntax to the motivation is part of the learning process. And what's so useful about looking at source code that has a high amount of comments is that it helps you understand why this text is appearing here. Why is this here? And I think that why is something that's often missing. If you just go on Chainweaver and you use the module explorer and you browse source code that's been deployed to the smart contract, a lot of Pact is human readable. You can read the code of any project that has deployed on to Chainweb, but you don't always know the motivation for why is this here. And that's what this code is so good at helping understand.
Yeah. And each of these will have like a little header that tells you like, what's the point of this contract before we get into like the full thing and all of its comments. If you are looking at this and you get really confused, like I don't really know enough Pact maybe to really look at this. If you go to the Faucet project and look at that one, this one is like basically a book on how do you write a Pact module. So I definitely recommend that one. So the more interesting parts of this, to me, of the protocol, include these are the Charka tokens. So this is what you get when you deposit into the protocol. So when I send Kadena, I'll get back this like interest rate bearing token called the Charka wrapped, and then whatever the name of the market token is. And so these ones are all, you can see this implements here. This is taking advantage of Pact's support for interfaces. And an interface is where you just write like what the functions are meant to be. Like here's an interface in which we say there's an accrue interest function, but then there's no body. It doesn't have any implementation. It's just the type of the function. And when you have a different module that then says I implement this interface, what you're saying is that I promise that every function that's described in that interface, I have provided an implementation for it. And if you then load it in the REPL and you run verify on it, as we saw with the formal verification test, it'll check that all of your functions indeed do match the interface. And in Kadena, in Pact, this is how you do things like implement your own tokens according to a standard, so that anybody can say, instead of just saying like, I support this token and this token and this token, instead you can say, I support any token, so long as it implements this fungible V2 interface. And so all of our tokens do implement that interface. And because they do, you can use them with like fundamental, like standard operations, like transferring coins, cross-chain transfers, stuff like that. That's what happens when you implement this interface. So every one of these market tokens, because it implements that interface, you know that I can, like when I have it, like I'm not just stuck holding this token and I can't do anything. Like I can trade this token, these interest rate tokens. I can send them to people. They can take on my debt. Like it's fully under your control. And part of the way you know that is because of this interface. So we implement our own one called a market interface, and that's saying like this is what all market tokens need to support. And this doesn't really have comments because the interface has the comments. But these are some of the functions that each of these markets has to support. Like
so just to read out some of the function names for those that maybe can't see the text, we have accrue interest and apply balance change and get participant and get borrow are some of the example functions. Yeah.
So when you see this interface, it's basically like, hey, I want to, there's this asset on chain, KDX or something, and I think that there should be a market for that. What you'd have to do is basically implement one of these contracts against this market interface. In order for you to use this with the protocol, you have to use this interface. And it's such a cool thing about Pact because it makes it so obvious, like what you have to do. And then I can build in here, I didn't in this module, but I can build in here tests. I can put in like formal verification models into the interface itself. And so you get tests for free as well. So I say, I'm going to implement my own accrue interest function. And I might, as the protocol, say, well, it has to behave in this certain kind of way. And so not only do you have to implement it, but it has to satisfy these tests as well. And Pact will check that for you. And so it really guides your development by having an interface to implement against. Right. So this is one of the big pieces. Each one of these tokens is one of the supported markets. So each one of those money markets that you see, if you're trying to understand how it works, click on any of these market tokens, and it's showing like, here's how you apply balance change and that kind of thing. The two other ones that are interesting, this one is the governance contract. So this is the thing that manages voting. How does voting work? The way that it works in general is that you can submit you can submit a proposal if you have Charka tokens, and then people can vote on that proposal while it's live. And their vote is tied to how much of the reward token they have. So if you have 10,000 Charka, then that counts as 10,000 votes, basically. And the way that you get Charka is by participating in the protocol. So the biggest market participants get to have the biggest vote. But since it's itself a money market, you can also lend your Charka to basically, I mean, you're basically selling your vote in that case. You're saying, you know what, I would like to earn some interest by letting you use my rewards to vote with until the vote closes, and then I'll take it back. So it's a whole like a little free market situation here. If the vote passes, then it automatically goes into effect. So we can see, for example, the market factors table here. This is stored for every market. So for every market, you have a base rate, which is the minimum interest rate the borrowers pay. You've got a multiplier. So this is if, say, the market is 80% utilized, like that's 0.8 times this multiplier is how we set the interest rate. So I think it defaults to 1. But you can set it even higher if you're saying, hey, at high utilization, I want interest rates to spike super high to try and bring the demand down. You can do that with the multiplier. The reserve factor we talked about before, this is the protocol holding back some funds to cover bad debts and other stuff it needs to function. And then finally, the collateral ratio is how much, like if I deposit 100 Cadena, how much can I borrow now? So a collateral ratio of 0.8 or 80% means I can borrow 80 Cadenas worth of another asset based off my 100 that I've lent. So it's always less than 1, the ratio. But these you can vote on. You can create a proposal. So here's the schema for a proposal. So it's what factor do I want to change and all that kind of stuff. But in here, submit proposal. So this is the function to actually make a proposal. You can say, this is my account, this is the market I want to target, and this is what I want to change. For example, I want to change the base rate on Cadena to be, or the multiplier in Cadena to be significantly higher, or something like that. This is the function that lets you do that. And then people can use this other function to vote on it. So we can look at the, oh, I think I stopped it running actually. Nope, it's still going. So here we can say like, that was the code for it, but here's like, you know, update base or multiplier, let's see, base rate for KDA. So we want to change the KDA market. We want to change the base rate, and we want it to be like 10% now. Oh, I don't have any Charka because I lent it all. I already lent it. So I'm not allowed to do this. Yeah,
you can't double dip, sadly.
Yeah. I need to get some of that back.
Oh, it might be the divide by 50 thing again, right?
It is. I need to change that text. Why can't I do this? Redeem, repay.
Well, as always with live demos, especially when Pact has been updated since the code was written, we sometimes run into little pieces. And what I would say here is, honestly, it's always a great opportunity if you're diving into code. If you want to understand how something really works, if something isn't working, you can go dive through and figure out why something isn't working and follow each of the logic chains. And that's often how I learn with new projects.
Last time I fixed it live, but this time I'll just change the I'll close voting on this one, which was already open, to change the base rate.
Cool.
For Charka. So we should see this borrow interest rate should change. So I'll come back to this in a moment to check it. But anyways, this is the governance process. And then when the proposal gets changed, if it goes through, you can see that we update the factors table. So like, I'll actually go back here. So if the vote is closed, then we tally the votes by looking up the balances of all the people who are voting for or against. And we just, your money is your vote. So that's what we compare here. And if it passed, then we change the proposal to be accepted. And then depending on what the factor was that we wanted to change, we go ahead and update it in the factors table. And at that point, or the proposal can fail if it didn't get enough votes. But once this happens, it immediately goes into effect. There's no intermediary again. If the community votes and they make the change, then it's done. And now the interest rates will use the new rates. And hopefully, did this? Yep, it went through, I think, but I'm not seeing a, I think the base rate might have already actually been 2%, but
yep.
Anyway. So yeah, so this is the governance contract. So all these contracts are pretty short, and that's what I meant by this being a reference. Like there's plenty that you could do to make this fancier and like put controls in. These are all meant to just be like the minimal implementation of how it's supposed to go.
Yeah, and what's so cool here is that this is all on-chain governance, right? So oftentimes when you see crypto projects that have some governance proposal process, there's still a human at the other end of it that's going to take the intention of the community and turn that into a change of the smart contract. And what's so cool here is that this is all protocol controlled, that the market has these factors. You can, submit this proposal, you can vote on it. And then if the vote passes, the protocol updates the rate. And that's freaking awesome.
And it's done. Yeah.
So the last voting there.
Yeah. The last thing that'll show really quickly is the controller. So this is like the top level contract. Like if you really want to understand this protocol and how it works, you can sort of like know at a high level how everything else works, but you do need to read this one and understand it. And so this is the thing that like, this is the core functions: borrowing, lending, liquidating, and that kind of thing. So we can just show one of these, all these like helper functions you can use here, but kind of long. So like supply, for example. So this is the function like that you would call. So like the UI is one way to use the protocol, but the UI is just like, it's to make it user friendly and something you can look at and click on buttons and like see your balances and everything. But you don't need that. I mean, this is a protocol on chain. You can completely bypass the UI and just write Pact code and submit it to the chain directly. There's no reason that you have to go through the UI in particular. So you can spin this up on DevNet and then spend some time like algorithmically like trading on it. If you wanted, you could try having little bots take out loans and supply to different markets, and then you could try to arbitrage back and forth and basically build your own little test arbitrager for this and like liquidator bot for this protocol. Those are fun exercises to build on top of this. So this is what you would actually be calling in your contract. You'd be calling supply from my account to this market. And we can take a quick read through here, like what happens, because again, there is no intermediary. Basically what happens is like, this is going to attempt to transfer your funds. So this is going to call like the coin contract. If you're supplying KDA, for example, this is going to call the coin v5 contract and transfer your KDA to the protocol. And this will only work if you've signed this transaction with like the transfer capability and uses the capability system that's very powerful in Pact. I'm not going to really talk about it. We talked about it quite a bit in the last video. But that's basically you saying, I will allow my signature to be used to make this transfer happen. And then this is the code that actually says, okay, transfer this stuff to the protocol. And then we'll write to that given market. We'll say, update the market to say that it now has these extra funds. They've supplied these funds to this. Apply balance change is going to give you your Charka wrapped tokens. And then we can update that market and we're done. Basically, you set your cadena, you were given your Charka wrapped token, and literally this is the full function for becoming a lender. It's like very, very small.
Yeah, so I hope people can look at that and say, wow, I followed all those concepts in terms of the things that needed to happen. And then look, it's actually a pretty minimal amount of code that's written. And of course, you can look up some more of those functions and follow it. But yeah, it's elegant how just on one screen, I mean, without all the comments, it's all of 10 lines of code.
Yeah, it's the whole thing. Some like the helpers are a little bit bigger, but like write and update, these are just built-in Pact functions. So it's really very, very small. And you can see here, like I was talking about interfaces before, where we've got this like token ref transfer. This is called a module reference, and this is where you can basically pass like a mutable reference to a contract. Like I don't say, like here I'm not saying cadena, this is like how I supply cadena, and then I write another function to supply Charka. It's not like that. I basically say I can supply anything so long as it's like in the markets table and there's a reference to the fungible v2 interface, a contract implementing that. And since the fungible v2 interface, or KIP5, guarantees that you must have a valid transfer function, I can just reference it out of the module. And so this supply works for any market so long as I've got a token that implements this interface. And so it's a really cool feature of Pact. It's used all over this project, these module references. It's what makes interfaces so useful. So definitely that's one of the big things to learn out of this whole project.
So cool.
Yep. And then the market ref is to the all of the data on the individual markets that we were looking at before. It's like each market here. And that's it. So there's a lot more in this contract. There's an implementation of each of those things, redeeming my my wrapped tokens in order to get back my actual balance. You can see like it's like calculating interest rates in here when you're borrowing. There's all kinds of stuff. There's also an interface for this, the controller interface, that explains more in detail what some of like the data being stored and all of that stuff. So definitely read through it if you're interested. It's pretty thoroughly commented about what the purpose of each of these contracts is. But I'll leave it there because it is a lot of code. It's too much to kind of go through in just a moment. But if you're interested in more advanced and more serious Pact development, it's a really good example to take a look at and just use it as a reference. Again, you're not supposed to just clone this and like use it. You're supposed to be like, hey, I'm trying to implement this thing, but like I'm running into these performance issues. I know that Charka definitely had to deal with this as well. Let's see how he handled it over there. You can look at the development guide, you can look at the white paper, you can look at the commented contracts, and you can look at the tests and figure out, what is it that I did to get around that issue.
Right on.
And that's it. That's the demo.
That's awesome, Thomas. So well done giving a demo of the interface live and testing the fate of the demo gods and
always,
pretty good battling average. And of course, there's always one or two things that pop up, and then diving into the code and walking us through some of the key pieces. So cool. I hope that that's of inspiration to folks. And if anyone has any questions, we can take maybe one or two. So feel free to pop in the chat. But otherwise, I think this has been a really great introduction to how people can build a more advanced application. And you're not going to walk out of this video and know how to build a lending platform, but you might walk out of this video with some of the inspiration to dive further into that code and some of the tutorials that are there. And within an hour or two of study, you might have a really good understanding of how to build a lending platform. And after playing around with the REPL and maybe even taking some of the ideas you mentioned, like trying to build a little arbitrage bot on top of a lending platform, there's a lot of fun projects that someone could dive into after looking at this. Or, of course, just playing around with some of the governance protocols and looking at, well, what happens if you get into these interesting places where one actor is trying to bump up, the interest rate on a particular pool and is borrowing Charka, and what happens in terms of the market and all that. There's super interesting, I think, aspects of the actual markets that can evolve from these kind of things and these so-called bribery mechanisms and ultimately lending platforms, and having this sort of on-chain governance trustless protocol is really, really freaking awesome. And I think it's pretty wildly cool to see that happen in a more trustless fashion than I think we've seen in a lot of other protocols. And so I think that's also just a technical achievement on its own right in terms of building that out. I think you should be proud of that. And I know those of us that look at the space see that and think, wow, that's pretty cool. Yeah.
I hope one of the big things that I hope that this delivers to people is just that you have a place to turn when you get stuck and you're like, God, I cannot, I'm trying to do this thing. I'm trying to write this test. I can't remember how to do it. But everything in this repo is we got automated tests on there and this formal verification. So despite my hiccups around setting a proper gas limit, for example, those things may not be guaranteed to be right. But all of the code itself, it functions just fine. And so I would recommend taking a look if you get stuck, taking a look at some of the test files and seeing if it can get you unstuck.
Right on. So cool. I see a builder in the chat has chimed in to share that they've just launched a new project today. So Philip, congrats on launching Marietta Jane's Casino. Sounds pretty interesting. I see Barbaric Puma in the chat has already interacted. But so cool. Joe, no worries if you're joining us late. You got a great 55-minute ride ahead of you, man. So stick with it.
Yeah.
And otherwise, I think we'll wrap up here. Thomas, thank you so much for joining the stream with us today. This has been a really awesome introduction to some new concepts, from module references to interfaces a bit more in depth, some more formal verification, some better understanding of how interfaces and formal verification can interplay for tests, how the sort of interface-driven development can help prompt people in terms of what smart contract code they need to write next. And finally, I think the general organization and saying, hey, if you're launching a new crypto Web3 project and you want to go about a nice open source code way of doing it, having something like a white paper to introduce all these core concepts, and having this structure in terms of the test code and the repo and the interfaces and everything is a really, really great blueprint. So I hope folks will look at this in depth. Even if you're not building a lending platform or have a different project in mind, there's going to be concepts here, from the testing and the code layout to the module references to all these module read writes and all the core nuts and bolts that will be applicable in terms of core concepts. And I think this is the first well-documented advanced Web3 project available for Pact. And so it's just an awesome resource to have for the community. And I see some appreciation coming in. So Thomas, thank you so much for all your work. And
yeah, thanks for watching.
Hope you have a good time building, and definitely check out the repos and let us know what you think. All right. Cheers, folks. Until next time.
Thanks so much. See you later.